Good afternoon, geometry students. We are continuing on in chapter 4 of our geometry book. I hope you're having a fantastic day. I can't wait to see you. We have not yet started quarter 3, but I'm already thinking about you. So we are on section 7.3 today, proving a quadrilateral is a parallelogram. Now, some of you are going to listen to these notes and think, I already took these notes. They sound really familiar to me. The reason why is because many of the words are going to be the same, but they're just in a different order. So what you may recall is that with lesson 7.2, the last lesson, we looked at a conditional statement that was in the form, if a quadrilateral is a parallelogram, then a bunch of things were true. You know, opposite sides are congruent, opposite angles are congruent, opposite sides are parallel, the diagonals bisect each other, and blah, blah, blah. Now, what we're doing today in this lesson is we are flipping the order. So for lesson 7.3, we're going to say if, and we're going to list one of the features and say then it's a parallelogram. So we are doing what's called the converse, where we switch the order. Now, we talked about converse last quarter for math, but you may not remember. But again, we are switching the if and the then. So, for example, we're going to say if both pairs of opposite sides are parallel, then the quadrilateral is a parallelogram. So it's the same information that we had on our last lesson, but we have switched the order. Instead of saying if a quadrilateral is a parallelogram, then the opposite sides are parallel, we're flipping it and saying if the opposite sides are parallel, then the quadrilateral is a parallelogram. So let's look at all the different ways we could prove a quadrilateral was a parallelogram. One of them is to say that if both pairs of opposite sides are parallel, then the quadrilateral is a parallelogram. In fact, let me just change this because I think it'll look a little bit neater if I go this way. There. Okay. The second bullet is that if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. Can anyone think of another one? How about if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. And we can also say if the diagonals bisect each other, then the quadrilateral is a parallelogram. Now, there is actually only one new one here. And this is called, and I'm going to give the name on this one. It's called, well, actually, let me give you the theorem and then we'll do the name for it. So this one's new. Let's put a little new here with a little star. If one pair of opposite sides is both, notice the word both, congruent and parallel, then. So all of the other requirements are we have to look at two pairs of opposite sides. You know, both pairs of opposite sides are parallel, or both pairs of opposite sides are congruent, or both pairs of opposite angles are congruent. But with this last one, we just need one pair, but that one pair has to be both parallel and congruent. This is called, this last one is called here, the opposite sides parallel and congruent theorem. The other ones would be called the converses. So this would be the opposite sides converse This would be the opposite angles converse, the parallelogram diagonals converse, and so on. All right, let's do some examples based on these notes that we just did. So let's take a look at example, well, let's just call this example 1, and I'm going to show several pictures here, and then we're going to see whether or not we have enough information to prove that the figure is a parallelogram. So under each one, we're going to write a yes or a no. Okay, now this is hopefully bringing back some memories about what our symbols mean. Remember, if both of these sides have the same number of hash marks, that's a way of saying they're congruent. And these triangles mean that the two sides are parallel. So would this be a yes or no? Do we have enough information to prove that this is a parallelogram? This would be a no, because we just have one pair of opposite sides that is parallel. How about this one right here? This one is also a no. We have one pair of opposite sides that's congruent and a different pair of opposite sides that is parallel, so that's not enough information. This one here would be a yes, because even though we only have one pair of opposite sides, they are both parallel and congruent. This one would also be a yes because we have two pairs of opposite sides that are congruent. And this would also be a yes because we have two pairs of opposite angles. All right, let's go ahead and do example number 2. We want to find the values of x and y that would make the figure a parallelogram. All right, so we know that opposite sides need to be congruent. So we can set 4x minus 1 equal to 3 times x plus 2. Let's go ahead and distribute. And then what we're going to do is subtract 3x from both sides. So we have x minus 1 is 6, or x is 7. So if x was 7, that pair of opposite sides would be congruent. Now, we also have to solve for y on this one. I would need 3 times y plus 1 to be equal to 4y minus 2. Again, we distribute. 3y plus 3 equals 4y minus 2. When I subtract 3y from both sides, I have 3 equals y minus 2. And then when I add 2, I get that y is 5. So in order for this to be a parallelogram, both pairs of opposite sides would need to be parallel, congruent. So x would have to be 7 and y would have to be 5. All right, let's do another example. Again, we want to find the values of x and y that would make the figure a parallelogram. In this case, we're looking at the diagonals. Now, we do need both diagonals to be bisected. So we would need to set y plus 3 equal to 2y minus 11 so that both pieces of that diagonal are congruent. And then we would also need to set 3x equal to 4x minus 3. when we subtract y, we get 3 equals y minus 11, or y equals 14. Here, subtracting the 3x, I get 0 equals x minus 3, or x equals 3. All right, we're going to do 2 more examples. Example number 4. This is kind of a cool example. It looks like we don't have enough information, but we actually do. We're given that one pair of opposite sides is congruent. So in order to prove that this is a parallelogram, I would need to be able to show that the opposite sides are also parallel. Now think back to earlier in the year, last quarter, we learned that if 2 lines crossed by a transversal have consecutive interior angles that are supplementary, then those 2 lines are parallel. So in other words, if 2x plus 5 plus 3x was equal to 180, the 2 lines would be parallel. So we can solve that equation, and we can note that if x is 35, then the 2 angles would be supplementary, which would make these 2 lines both parallel and congruent. All right, one last example, example number 5. Again, on all of these, we're trying to find the value of x and y that would make the parallelogram, or the quadrilateral, a parallelogram. So this is going to be x plus y and 20, and then 2x and 24. So on this one, I think it can be a little bit helpful to draw 2 parallel lines crossed by a transversal. We did this on our last notes. And notice, as I mentioned before, that the alternate interiors would need to be congruent. So we would need 2x to be 24 or x to be 12. We know that if the alternate interior angles are congruent, then the lines are parallel. So if 2x was equal to 24, or if x was 12, those 2 lines would be parallel. We can do the same thing for the other 2 lines. We would set x plus y equal to 20. I just found out that x was 12, so I can say 12 plus y is 20, or y is 8. If y was 8 and x was 12, the other pair of alternate interior angles would be congruent, which would make the other pair of sides also parallel. All right, I know that was a lot to digest. I'm really proud of you for taking those notes, and I'm looking forward to helping you on the homework. Thanks so much. Bye.